Okay, so everybody very quickly corrected my picture here by putting this point over here where it belongs. And we got this plane in this direction, and now that's compatible with the direction that we perceive for the normal vector, okay? At least the way I drew it incorrectly. Make sense? Okay, now, these two planes very clearly intersect right here where the green line is drawn right over the white line, okay? And of course, this is a plane 9x minus, this is a plane that we were after originally. There's an 86.1 there, okay? And this is the plane that I accidentally drew by ignoring my negative sign, not writing it down. Again, not being careful enough, okay? Algebraically, we can find the intersection. We have this plane, which consists of all the x, y, z coordinates that satisfy this equation. Right? We have this plane, which consists of all the x, y, z coordinates that satisfy this equation. Now, planes intersect, if they do, where? Well, where x, y, z is on both planes. The values of x, y, z are on both planes. And x, y, z is on both planes if and only if x, y, z satisfies both of these equations. So now we have a system of two simultaneous equations. Okay? So, okay. Well, we can do one of two things. Since all these numbers are the same except for the signs of the y's, we could add the two equations, okay? And we'd eliminate y. Okay? We could also subtract the two equations and eliminate both x and z. Well, we're going to choose to eliminate just one variable, reasons that you want to think about. Okay? We get this. Sorry?
Z, not Y.
Yeah, z, not y. Okay? Subtracting. Okay? And I'd say subtracting the equation, subtracting the second equation from the first. Okay, first minus second. We could do second minus first, we get positive 2. Okay? But it's clear that the x and z would cancel, they'd add up to 0.
Is what we're trying to find the vector that the two connect? That's what we're trying to find?
So we're trying to find the equation of the line.
Oh,
Okay? Now, I'm thinking in terms of finding a vector and so forth is a good idea, because this will give us a vector. Okay, but this means that y is 0, right? Now, what does it mean for y to be 0? It means that we're in the xz plane. It means that y is 0, so we're in this plane. Well, is that intersection in the plane? It better be, right? I mean, the equations had better give us an intersection that's in the xz plane, because that's where the intersection clearly is. Okay? And then in the xz plane, this equation has intercepts approximately 105, 0, 0. You can solve it. But 172.2 over 1.8 is the same as 86.1 over 0.9, because 172 is just a double of this, and the 0.9, the 1.8 is a double of 0.9. And here it's okay. Okay, well, we're a minute over. So that should be enough. And we're actually anticipating the next two sections.